When's the best time to talk about fourth normal form? Clearly, after fifth normal form. Welcome to this video on database normalization. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Last time around, we looked at fifth normal form. Today, we're going to go back down to fourth normal form. Now, let's get back to school. Hello again, class. Today's topic, if you haven't already heard, is fourth normal form. You might be asking yourself, why are we covering fourth normal form after fifth normal form? There are two reasons for that. First, because I need a certain number of lectures for this series to count toward my tenure. Second, because fourth normal form is an anachronism, but a useful one nonetheless. This is the definition of fourth normal form. It states that a rel var R is in fourth normal form if and only if every multi-valued dependency of R is implied in the keys of R. There's one new term we haven't heard of before, a multi-valued dependency. Otherwise, this definition looks very similar to fifth normal form, and that's for good reason. Fourth normal form is a special case of fifth normal form. We'll see this even more clearly when I explain what a multi-valued dependency is. Put simply, a multi-valued dependency is a join dependency with exactly two components. So fourth normal form covers sets of join dependencies, each of which has exactly two components. Meanwhile, fifth normal form covers sets of join dependencies with any number of components, not just two. At this point, you might be wondering why fourth normal form even exists if it's just a subset of fifth normal form. And that is entirely due to an accident of history. The academic paper outlining fourth normal form came out prior to the papers for Project Join normal form. It wasn't until fifth normal form came to be that people realized fourth normal form could be rewritten as a proper subset of fifth normal form. History lesson aside, let's make sure we're all clear on what a multi-valued dependency is. You've seen an example of this already. The album sales rel var has a key of artist, album, and sales country. In this rel var, we note that artist R is on album A, and album A is for sale in sales country S. The way that I phrased this gives away the game already. When we look at this as a set of join dependencies, we end up with something like this, where one join dependency combines album and artist, and the other covers album and sales country. Therefore, we have two join dependencies, each of which has exactly two components. By the way, if you're ever digging into the old fourth normal form literature, you may see a double arrow linking things instead of the curly braces we use for join dependencies. That notation is older than the join dependency notation, so it may still be kicking around in a few places. But the upshot is that these three notations all mean the same thing, so to minimize confusion, I'm going to keep using the join dependency notation. Now, let's take another academic sidestep and talk about something called Fagan's theorem. Fagan's theorem says that a rel var R can be non-loss decomposed into its components x, y, and x, z if and only if there are two separate join dependencies in R, one which contains x and y, and the other which contains x and z. What's nice about this theorem is, as we recall from Heath's theorem in a prior lecture, y and z are generic. They don't have to mean one attribute. Yes, in fourth normal form, y and z are individual attributes, but the same still holds even if we have 3 or 4 or 5 attributes in a join dependency. Another way of putting Fagan's theorem is, if there are multiple independent attributes on a rel var, split them out into separate rel vars. It turns out that artist and sales country are independent of one another, and so we should have two separate rel vars, one which contains the combination of album and artist, and the other which contains album and sales country. This solves a variety of problems. First up, we avoid needing multiple copies of the same record. We need 2 copies of Band 1 and 2 copies of Band 2 because we're selling in 2 countries. Each new country we sell the album in, we always need an additional copy of Band 1 and an additional copy of Band 2. If we miss one of these, we can run into problems. Second, as we mentioned in the 5th normal form lecture, any single update or deletion likely needs to hit multiple tuples, and that's a code smell for database design. At this point, you may be asking yourself, isn't there another way around this problem? The answer is yes, but they're all bad ways. Let's take a peek. Within our company, we like to keep track of what skills our employees have, as well as languages other than English that they know. Fred is one of our employees. He has a great singing voice and does a pretty good job editing music videos. Fred is also conversant in French, German, and Greek. This is the disjoint format for storing data. There are 2 major problems with this. The first problem is, what do those blanks mean? The second problem is, what if Fred doesn't know any languages aside from English? We could learn this from the lack of tuples containing a value for language, but then we might ask, what is the language attribute doing here? Here's a second approach in which we pack things into the minimum number of tuples and allow blanks, or horror of horrors, null. If we read this, we can immediately see the problem. Based on this data, we can infer that Fred can sing in French and edit German music videos. In that case, what does he do in Greek? Actually, don't answer that. Also, what happens if Fred is no longer conversant in German? In that case, we would need to have full knowledge of all tuples and shuffle things around, updating multiple tuples in a non-trivial fashion to maintain our minimal solution. Here is a third example, which includes the minimum number of tuples plus some repetition to avoid null. Yes, we avoid null, so that's marginally better than the prior example, but it's still bad. Reading this, we assume that Fred can sing in French and can edit German or Greek videos. Because of the repetition, it actually becomes more ingrained in us that the skill and language are supposed to be together, even though that wasn't the original intent. Now, let's ask a few questions. First, what if Fred is no longer conversant in German? Well, in that case, we can delete a single tuple. That's a good start. But what if, instead, he's no longer capable of editing music videos? Now we need to update multiple tuples and set the skill to sing. And a third example. What if he is no longer conversant in French? In that case, we need to delete a tuple and then update one of the 2 remaining tuples. Even worse, if there were no duplicate skill tuples available, we'd need to update the sing tuple and change the language rather than deleting it. So again, we have a lot of complexity here and need to know everything about the full set of tuples related to Fred in order to perform any action. That can be disastrous in the case that multiple people are working on Fred's skill set at the same time. And then let's go all willy-nilly with this 4th example. Actually, never go full willy-nilly. In this case, people can insert whatever they want and the app will figure it out later. So we have nulls or blanks, we have repetition, we have confusing combinations, the works. The one good solution is to break the join dependencies out into separate relvars, where we have employee and skill, and then employee and language. Doing this solves the problem. It turns out that the join dependency employee skill language was good enough for Boyce Codd normal form because all 3 made up the candidate key. But because there were 2 independent attributes in the candidate key, they created 2 join dependencies, and we need to break it out. This is another reiteration of the fact that Boyce Codd normal form is great, but it isn't enough when you have multi-attribute candidate keys. And as we wrap up this lesson, I'm going to return to tier maker. I hope this lesson explains why I consider 4th normal form to be overrated and in the B tier. at the bottom end of the B tier, B- tier. We don't ever need to think in terms of fourth normal form. We can solve the problem entirely in the language and constructs of fifth normal form. But fourth normal form isn't quite as low quality as second or third because the types of problems fourth normal form solves are simpler versions of the more general 5NF problem, and I suppose I'm feeling a bit more generous about it because of that. Class dismissed. That's gonna do it for fourth normal form. Because there's no real advantage in being in fourth normal form but not fifth, I recommend thinking about the paths as first to Boyce Codd to fifth, ignoring everything else in between. In the next video, we are gonna move back up the chain again, this time tackling sixth normal form. We'll have links and show notes in the description below. And until we see each other in the next video, take care.